In this example, we have that an airplane coming up to its destination will begin its descent approximately 100 miles from the airstrip at an angle of depression of 6 degrees. At what elevation in feet will the plane begin its descent? We will round that answer to the nearest foot. We are also going to solve the second part of the problem that says, assuming the plane follows a straight line descent to the airstrip and using the concept of similar triangles, how far from the strip is the plane when it is at an elevation of 4 miles? Alright, so for the first part of this problem, what is really important when solving questions concerning angle measures and side lengths in trigonometry is that we are very careful that we know how the angle measures and the side lengths relate to each other. By that I mean, in what position is my angle measure and in what position are the side lengths relative to that angle measure in question. For this situation, one of the most important parts of this is that this says that we have an angle of depression. What that means is that we are going to draw this in a very particular fashion. If you ever see the phrase angle of elevation or angle of depression, what that means is that we are going to be drawing an angle measure from a horizontal line. So, for this case, I'm going to draw my plane over there, and we're going to draw a horizontal line from the plane's position up in the sky. An angle of elevation would imply that from that horizontal, the plane is lifting up into the sky. That would be an angle of elevation. However, for us, we have an angle of depression, which means from that horizontal, we will draw an angle measure down. That diagonal that extends from that and the angle measure in between will represent our angle of depression. So this is where I will draw my 6 degrees, and I will connect this to create a right triangle. This is very important because you could very easily put the angle measure in the wrong position. A common mistake that I tend to see is that students would instead draw the triangle coming down from the plane like this, simply because many like to draw right triangles with a flat horizontal line on the bottom, and would put the 6 degree angle measure here instead. But that would end up being incorrect. That angle measure there is actually the complement of 6 degrees. So let's use the appropriate version of this. We have that 6 degree angle measure. We are also told that this airplane begins its descent about 100 miles from the airstrip. So that means the distance to the airstrip is about 100 miles. And we are trying to find at what elevation will the plane begin its descent. That means that we are trying to find the height of the airplane. We're going to find that value in feet, but we'll take care of that in a moment. For now, we need to make sure that we draw our picture correctly. From there, we can then determine what trig function is going to be the most appropriate in order to solve this problem. We typically do not need all trig functions sine, cosine, and tangent to solve for any given problem. We should only need one of those. Which one depends on where my angle measure is and what side lengths we know or want to solve. In this case, the angle measure we have here is the 6 degrees. We have the side that is adjacent to it, that is next to it, and we are trying to solve for the side length that is opposite of it. If you look at the 3 basic trig functions, by that I mean sine, cosine, and tangent, there's only one trig function that connects both the adjacent side and the opposite side, and that is tangent. Tangent of theta is defined as the ratio of the opposite side over the adjacent side. We would not use sine or cosine because that would require knowing the hypotenuse side, which we do not have in this case. If we plug things in accordingly here, Tangent of theta, which represents our angle measure, that will be 6 degrees in this case, will equal the ratio of opposite over adjacent. Our opposite we indicated earlier is x, and our adjacent is 100. If I need to solve for x, I simply need to multiply 100 to the left. You get 100 tangent of 6 degrees is equal to x. Now, to solve for that, we are going to need to use a calculator, particularly since we are going to be approximating. So, if I bring a calculator over into this problem, we are solving 100 times tangent of 6 degrees. Note that the argument inside of the trig function is a degree measure. Make sure first that you are in the correct mode for this. Depending on your calculator, the correct mode is either the first, second, or third option. It's usually near the top. And you need to make sure in this case, since we are plugging in degrees, that we are selected in degree mode. Once I have verified that, I should be able to plug this in accordingly. 100 times tangent, and inside the tangent function, I will plug in 6. Because it is already in degree mode, it knows to accept that as a degree measure. 100 times tangent of 6 will give me an answer of 10.51. That's what I'll use as my approximate here. Now we are almost done. I would say that we are done at that point because we have rounded. However, at this case, this is 10.51 miles, and the question does ask us to change this into feet. From the parenthetical statement above, we have that note that 5280 feet is equal to 1 mile. Using that, I should be able to take my amount of miles, 10.51, and multiply that by 5280 to get the appropriate number of feet. It asks us to round this to the nearest whole foot, so we will say 55,495 feet. That would be my answer to the first part of this problem. The second part of this problem says, assuming that we are following at a straight line descent to the airstrip and using concept of similar triangles, how far from the strip is the plane when it is at an elevation of 4 miles? What that means is that we still have a version of this triangle. The plane has just continued down its descent a part of the way. We knew originally it was at around 10.5 miles up in the sky, and now it is at an elevation of 4 miles. So approximately it has gone a little bit more than halfway. So I now have my plane that is not as far away from the airstrip as it was before. And we now know that the elevation is 4 miles. And because it's still using the same similar triangle, that means the angle measures within the triangle are consistent, meaning that this angle measure here is still 6 degrees. Now we are trying to find how far from the strip is the plane when it's at an elevation of 4 miles. So we're trying to solve for x this time. This one asks us to keep it as a mile, so we will do so, but this is going to be a very similar setup. If I still apply tangent, because my angle measure, I am trying to solve for the adjacent, I have the opposite. I will plug this in as tangent of 6 degrees is equal to the opposite, which is this time 4, over my adjacent, which I've labeled as x. I'll move this up ever so slightly so I have a little bit more room. If I multiply both sides of this equation by x, and then divide both sides by the expression tangent of 6 degrees, I will get that x is equal to 4 divided by tangent of 6 degrees. Like before, I can now go into my calculator and approximate this. In this case, I'm going to take 4, I'm going to divide by tangent, and yet again plug in 6 inside of tangent. Note that we know that we've already progressed some part of the way, and probably a little bit more than halfway. We were originally 100 miles, so I do anticipate that I am more than halfway there, and I would expect a number less than 50 miles. Let's see what we get here. We get 38 for the 100th, 0.06. So x would equal about 38.06, and that is in miles. That would be the solution to the second part of this problem.